Hi, I want to make a quick video just showing some things that a lot of students struggle with for initially getting started with R, specifically loading data. Okay, so by far, loading data is probably the most frustrating and difficult aspect of R. Once you get past this hurdle, things smooth out very quickly. My experience is that once students get the data into the system, they tend to figure it out with some trial and error. I know that this step is frustrating. If you need help, shoot me an email through Canvas. Go ahead and you can send me your data. Please don't send me anything in a zip file. Please send a format that Canvas can display for me, just so that I know I'm not receiving a virus. But send it to me. I'll be more than happy to help you out on this. Okay, so first and foremost is that data can be stored in a lot of different formats, and every format has advantages and disadvantages. What you have to do at this point in our careers is learn how to read whatever format is given to you. So you found some data, you love this data, you're interested in this data, you want to analyze this data. So you need to put it into the system. Okay, so what we need to do, we need to figure out how is it formatted, and then we find the function that handles that type of format. We take the function, take the data in R, boom, we've got our data loaded in R, and we're ready to go. So there are tons and tons of functions for achieving this goal. If you're new to programming, I suggest you use base R functions. If you don't know the difference between different things I talk about, use the base R ways. Go with the ones that I recommend, because those will probably be the easiest to get into initially. Now, if you're a little bit more advanced and you have a stronger computer programming background, consider using the other packages that have better features than base R. Basically, R has been around for a really long time, and as time has gone on, new functions were built to be improvements of old versions. And the base R is like the old versions of stuff. They work very well. Think of the base R functions a lot of times are kind of like Chevy F-150s. Sorry, Ford F-150s. Ford F-150s. All right, Ford figured out trucks really well way back in the day. And since they figured it out, they really haven't changed anything, because those trucks largely are the same as they were several decades ago, because they got it right. So anytime you see a mechanical device or code that has sustained over time without very many changes, it's probably pretty reliable, probably a pretty good way to go. Now, if you think about the cars that are new models are coming out every year, well, it hasn't been tried very much. It hasn't been tested. Since it hasn't been vetted, there's probably going to be some features that aren't as good as they would be if you bought a later version of that vehicle, of that machine. So, the same is very true of coding, the functions that we have in different packages. Okay, so base R is a good choice in almost every situation. If you're doing big data, it can be a poor choice, but at this point in this stage in the game, this is a good choice for to go with. The one major flaw with this is one thing that is a pain in the neck about R, is that what it's going to do. If it sees a character string, by default, it's going to load it as a factor. So let's say we have people's names. Those are called character strings. Those are like, if I have letters, it's not, our levels of data, we have ratio data, we have interval data, we have ordinal data, and we have nominal data. Well, if R sees something other than numbers, what it's going to do is going to go, hey, that looks like something that's not a numeric piece of data. So numeric is interval and ratio. Since it's not numeric, I'm going to go ahead and if I'm in base R, it's going to say this is a factor. Factors are difficult to work with. If you're using a factor, like early on in the course, don't worry about it so much, just roll with it. But for your semester project, make sure you contact me, and we'll take a look and make sure that you're handling your nominal data correctly, or ordinal data. Now, read R is probably the most common way of reading data into R. So this is a package in R. This has a collection of functions that bring utility to us. Now, these are a lot faster. These work a lot better. There's a lot of improvements over the base R, but there's still a little bit of learning curve with these that you have to go through. And sometimes it's not too bad. Sometimes it can be a little bit frustrating. And we need to be flexible. If you have big data, read.table is what you want to use. By far, hands down, that's the way you want to go. Read.R is comparable on medium-sized data sets, but for big data, data.table is the package that will work for you the best. One huge disadvantage of this is that it has special syntax that you need to learn. I've learned it. I've used it professionally. It works very well. I am honestly shocked at how well it works, but there is a bigger learning curve. So I believe that for the vast majority of students in the class, the base R functions are going to work out. But the exception to that would be if there is a file type that base R doesn't handle, then you're going to need to go to something else. Read R is what I usually use at work because it's pretty simple once you lose it. And then data.table, that package is a good choice when I have big data. All right, so what we have to do, my first step when I get data is say, hey, how is this saved? How is this formatted? Once I figure that out, I can proceed. So if I have white space separated data, so this will be like the data from the textbook's website, I'm going to use read.table. In read R, you can see it's read_table. And so you can, if you look down this list where I see a dot, in general, I have an underscore. It's not a perfect rule, but you can see the correspondence. Now, these two functions will behave very differently when I look at the parameters, but as an initial way to look, this is, I know which function I'm looking at if I know which function, or I know which read R function to pick, if I know which base R function to pick. If you don't know what to do, go with base R. And then comma separated file, read.csv, semicolon separated file, read.csv2. Tab delimited file, read.delim. Fixed with format is read.fwf. So in this situation, data is stored and you're told that like names appear in positions 5 through 30, something like that. So they count each position on the file and they'll tell you in a separate like data set, metadata, they'll say the positions 5 through 30 are names. And what you have to do, and that that position, if it's in if it is in position 5, that is the beginning of a name, and you know that position 30, if you see something there, that's going to be the end of a name. Now, if it's an unknown format, try read_file. R will try to figure out what to go with. Now, if you want to read lines from a connection, so this is a lot of times, this can be a website, or this can be something we type in manually. It's read lines. And if I have other formats I'm unsure about what to do, maybe it's exotic, maybe it's weird, maybe someone did something strange because they felt like it. A lot of times read.table has the capabilities, but we have to adjust the parameters. I'm going to go ahead and bet money that, whoops, oh, I feel stupid. There we go. I'll go ahead and bet money that these two will satisfy your needs for the vast majority of cases, as long as it's not an Excel file. Excel files are kind of a pain. And that's true with any software system that you're using, because Excel does a lot of stuff under the hood. So any time that you read an Excel file, you're going to need a special function. I don't care if it's SAS or Python or R or whatever. Okay, let me see something. Okay, I'm going to skip ahead. X. I want to talk about reading data from Excel. All right, so R really does not have a lot of good options for reading data from Excel files. It's for the amount of data stored in Excel files, it's surprisingly cumbersome in R. So if you see a .xlsx or a .xls at the end of your file path, you know that that is an Excel file. And my experience by far is that the read XL package is the best choice to use. If you don't know what you're doing, start here. And then using the read_XL function is probably the way you want to go. There's a few variations of that for specialized Excel files, but this is the one you want to key in on. I usually use read XL or I use open XLSX at work. This one is a good choice if you have like big data or you have a large number of data sets to work with at one time. I use it because I frequently have a large number of data sets I have to work with at once. So read.xlsx is honestly, if you look at the internet, this is like the standard in online. And I personally have had the experience that this is overrated. I wouldn't send you this way. If you were my brother or my sister and you're like, hey, I need to do this in R, I would not send you to this program first. The GData package has like an extra intermediate step using Perl, and it has a lot of good features, but starting out, it's a poor choice. I've never found it to be a better option than the others, personally. And there's another package, XL Connect, that according to the videos online, according to the help documentation, it's the bee's knees. I have not found it to be a good choice for what I do at work. It enables you to do things like change the color of cells and automatically, and do things like change fonts in an Excel file, but really you should, for most of our use, it's not worth it. I would say almost everybody in this class can get by with read XL : read_XL. Okay, so I just listed out several packages that you could be using. Okay, so this is, first of all, a confusing aspect of R. That conceptually, what we're going to do, we find the format of our data, then we find the function that loads that type of data, then we find what package contains that function. So what we have to do, we have to make sure that that package is available on our machine. So what we need to do is to load that on our machine, we need to use the install.packages function. So let's say I want read R on my machine. I'm going to go install, oh, and ooh, that I needs to be lowercase. There we go. I hate autocorrect so deeply. This bit of code right here will automatically initiate things to load the read R package into R for us. Now that means it's available. That doesn't mean it's active. That doesn't mean I can access it. What I do to make it accessible, I have to say, hey, R, I need to be using these functions. Now, why is it that I have to load packages? Well, R is big. R has a lot of packages. It's open source. There are like unbelievably many packages. And what will happen is that people reuse names. And if they reuse names and I try to call a function name and it's reused, R doesn't know which one to go with. And it's called package confusion. So what I do, I only load the packages I'm going to be using. And so we use the library function read R. Notice that I have quotations when I install .packages, but when I do library, I don't. Now, one of the tricks that you'll see me use a lot is the double colon. because a lot of times I don't want the entire suite of functions. I just need that function one time, and I'm not going to bother with it again. So I'm not going to put the time and effort into loading the package. So what I do is I use the package name that contains the function, colon, colon, that tells R that this is a package, pull out this function, and then it'll activate that for me. I'll do an example in a moment. All right, so that tells me when I have a package, when I have a function, how do I get it going? That doesn't tell R where to look for my data. That's what I'm going to talk about at this moment. This is a lot. I know this feels like you're drinking from a fire hose. I've been there with you. I've been frustrated. I've been the one screaming at my laptop over R. I feel you. I appreciate your pain. You need help, reach out to me. I'm here for you. Okay, so what we're going to do at the command line, you notice a little caret or the inequality symbol, whatever you want to call it. I'm going to type in file.path, choose.files, exactly as I have here. What that's going to do in a Windows machine, and I think it works on Macs, but I usually use Windows machines more than anything else. It's going to pop up a GUI, and it's going to show me. It's going to be very similar to Windows File Explorer. I'm going to be able to click around, find my file, and that's going to be the file path. I'm going to copy and paste that into my code to get it to read. Okay, so let's go ahead and execute that and take a look. So I'm going to hit stop share. Now I'm going to share screen. Okay, so now I've got my code going. So you'll notice that I use the R GUI. This is the simplest version of R that you can get. This is what I use professionally instead of RStudio. Why? Because there's RStudio adds some features to it that is not in the R GUI, and I find that those features frankly inhibit my exploration of data. If I need to modify my code, I end up fighting with the autocomplete too much. So I personally don't use RStudio. It's a lot of good features. A lot of people prefer it, but for me, I find that this is a better way to work professionally. All right, so let's say I have the Titanic data set on this machine right now. I want to load this into R. What I'm going to do, I'm going to do file.path, choose.files, like this. I'm going to press enter. All right, you see that a GUI came up. I'm pointing to the screen. You can't see my fingers. A GUI came up. What I'm going to do, I'm going to go through and I'm going to find where that file is stored. I'm doing this on a Windows machine. I believe this works on Macs. Other operating systems, usually, if you're using something like Ubuntu, usually I don't have to explain anything. Students just know what they're doing anyway. Okay, so I know where things are stored because so I have it stored in the folder for a previous semester of this class. Oh, actually, I'm gonna go off on a tangent for a moment. If you look here, you see how I have my files organized? You notice I have graphics, input, output, R. Okay, this is the way that I organize my files when I work on a project. R is where I store my code. Input is where I store my data. Output is where I store files that I build or documents that I build in the process. And graphics are any visualizations I build in the process. And I find that this is a very good system for working out. I did not come up with this. I learned this from Data Camp, by the way, but I have found that this is a very good way to organize my projects. So what I do, I create a folder for the project, and then, so 2020 fall, and then I organize everything within that folder in this format. And I find that it, so down the road when I need to reuse my code, I know it's going to be in the R folder. Or someone goes, hey, there was something funny about your output. What data were you using? And this has happened to me repeatedly at work. I go to my input folder, I find the data, and I check to make sure. Sometimes I had bad data, and my analysis was wrong because of the data I received. And frankly, you know, there's times that you just can't catch that. By being organized, I can always protect myself from having problems. Okay, so I go to my input. Now here is the Titanic data set. So I'm going to go click like this. Now, do you see that this long file path came through? All right, so you can see that on my machine, it's in the C drive, users folders, the errands NID that folder, desktop, SCA 416, 2020 spring folder, input, and then the actual file name. What I'm going to do, I go over here in my script. In this part of my script, let's go ahead and go Titanic is equal to, or is defined as read.table. Let's go ahead and say that this is its file equals to that. You notice I go ahead and I paste the entire thing. Those with strong computer science backgrounds, I know you're going to say something about working directories and that this is poor practice. I don't care. This works very well for the projects that we're working on. You have a good point. I don't care. I'm going to go ahead and say header equals true. Now, the header of a file is the column names. If I have column names, header equals true. If I don't have column names, header equals false. And so the first row of data may not be data, may be the column names. And then let's go ahead and go strings as factors equals false. So you'll notice that anything logical is going to be capital, all caps true or all caps false. Oh, shoot, it was a .csv. I thought I had it stored in a different format. Okay, so the mistake I got here, I'm embarrassed. I didn't mean to make this mistake. Okay, if I look at this, you'll see that this is a .csv, which means I need read.csv, and I put read.table, which is for white space. All right, so now I've got it loaded. I want to know, hey, did I get it in correctly? All right, well, here by using head, I print the first 6 rows and I can see what's going on. If I want, I can go tail. Oops, almost got it. And it'll give me the last 6 rows by default. If I want, let's say instead of 6 rows, I want 10, I just put comma 10. Boom, I got it. Okay, okay. Well, let's do this again, but this time, what we're going to do is we're going to go ahead and do this for an Excel example. Let's do this. I am going to do install.packages. Now this is already installed on my machine, but let's just do it. So we want read Excel. Install.packages, read Excel. All right, so what it's going to do, it's going to ask me where to look in the internet does it want it. Just go with 0 cloud. The one that it automatically picks, just hit OK. That's the best one to use if you don't know otherwise. Honestly, I find that it's the best one to work with. All right, so now that all this tells me is that read Excel is now on my system. Since it's on my system, I can use any function in there. So let's go ahead and let's get another data set. This one's going to be a school grades data set within the state of Florida. So let's do file.path, choose.files, and I'm going to start looking through desktop, 4164. I'm picking a previous semester of this course. Input is where I store my data, and it's called copy of school grades. And I get the full path. And let's go ahead and just call that school. Read Excel, read underscore Excel. All right, so now I can't remember the parameters of read underscore Excel. Honestly, off the top of my head, I can't remember it. I use it almost every day. For some reason, I'm drawing a blank. So what I'm going to do, I can do this. I can go read Excel, read underscore Excel. And if I just print that, it'll give me some information about the function. Also, I have the option of hitting question mark. Now, I don't know if Zoom is going to show you this. If I do this, I don't think it's going to show it. It's going to use my browser, my default browser, to open up a file, an HTML file. So I'm going to go ahead and hit it. All right, I don't think, okay, so on my screen, I can see help documentation. I don't know if Zoom pulls it up. Go ahead and just try it on your own if you want to see what's going on. But here, I can do path is equal to this. You see how it says path? And then I have the choice of sheet. Let's see what happens. Okay, so let's look at head. All right, so something about Excel files. Excel files are used by people who really don't know data science. I mean, that's something that once you get into working with data, you'll find that those who just always use Excel files, I call them Excel rangers or spreadsheet rangers. They don't know what they're doing. They think they know what they're doing. Don't fight them on it. Don't argue with them. It's just not worth your time. You don't know what you don't know. So a lot of times there'll be issues with the file treating it as a data set. And the printout here is basically our saying, hey, there's problems with these data sets or with the data set, and this is how I handled them. All right, so here is the data. Okay, so this is, oh, I forgot all about this. Something you want to do, you want to do as.data.frame. It loaded it as a tibble. A tibble is a special data storage format. It's not backwards compatible with other features in R, so I suggest you don't use it. Now, I'm going to use school. There we go. I've got my data going. Okay, so look at this. If I take a look at this, I can see that I do not have informative column headers. I can see that I've got a bunch of blanks. Then I have some text. So like, let's say I look here, I've got district name, and then I have Alachua, which I know is a district name. It's where Gainesville is. I went to school in Gainesville, by the way. And we can look through, and I go down to see what's going on. I see that we've got JJ Finley in here. That's where my daughter went to school for a few years. So it looks like it didn't load correctly. Well, what happened? Well, there's basically some rows that are just in the way for us. So what I'm going to do, I'm going to go back. Oh, hitting Control L, press Control, then L clears all the stuff in this workspace. So it just cleans it up for you immediately. Let's go ahead and go read Excel, read Excel, like that. Range, call names, skip. I'm going to use skip. Skip says, hey, skip some lines. Let's do this. Put a comma. Skip is equal to head school. And it looks like we need to skip 1, 2, 3 or 4. Let's see what happens. Let's go head school. Now, this stuff, a lot of times when you're dealing with Excel spreadsheets, there's going to be some kind of problem that the system encounters because Excel spreadsheets really are not used for, it's like people use Excel spreadsheets for humans to read data, not computers to read data. And we have to be able to move between formats of computers reading data and humans reading data. It will be the bane of your existence if you get into data. All right, now let's check this out. Yeah, this is good. This is good stuff. Now I've got district number, and then I've got district name, Alachua, school number, which, I mean, that looked like a school number to me, school name. And so I know that J.J. Finley, which just happens to be the very first one in the data set where my daughter went to elementary school. It is really close to UF's stadium. And I can see grade information. I can look through, look at the data. They were a C. I'm a bad parent. I sent my daughter to a C school. All right, so I've got the data, and now I can start working with it. And I'm feeling pretty good. This is a good format. So something we want to do, we want to use as.data frame wrapped around Read Excel to strip out the Tibble format, just because Tibbles are not backwards compatible with some functions in R. If you look at the internet, they'll say, yes, it is. It's perfectly great. Go ahead and use it. No. It's like when you start getting into more complicated projects, you step away from the tidyverse because the tidyverse doesn't have everything. There's problems. See anything else? No, that's all I got for you right now. I'll go ahead and post this in Canvas. If you have problems, reach out to me. Before coronavirus, I would do this face to face. I would every single student pull up their data, and I would go around the room and make sure they got their data loaded. Coronavirus world, well, you're on your own, but I'm still here for you. I'm just not as easily accessible. I'm more than happy to help you out. We can do a Zoom session. We can work it out. We'll work this out together. I'm here for you. Take care and goodbye.